Grand Touring Motorsports started as a social group of car enthusiasts, but we've expanded into all sorts of motorsports disciplines, and we want to share our stories with you. Years of racing, wrenching, and motorsports experience brings together a top-notch collection of knowledge and information through our podcast, Brake Fix.
When you first start out in motorsports, the essentials are always the same: better brake pads, stickier tires, and more seat time. For those of you who have had the pleasure of riding with one of our distinguished GTMers known as Crutch, who is on in season 1, you know that he has a reputation. It isn't for how fast his cars are, because they aren't, but he has a reputation for dropping anchor. He brakes hard, he brakes late, and because he has confidence in his equipment, he can do this. He only has such confidence because he has invested the time and research into upgrading his brakes. New brake pads alone aren't the answer because there are a few extras to consider when you're upgrading your brakes. And with us tonight is Wendy Charlier, General Manager for Porterfield Brakes, an industry leader in performance brakes, joining us for a technical chat about what's stopping you. So welcome to Brake Fix, Wendy.
Hi. Thanks for having me.
So like all good Brake Fix episodes, we like to start off with an origin story. So tell us about the who, what, when, and where of Porterfield, and where does the brand come from in the company history?
So back in the late 80s, Andy Porterfield was approached by Rotor Racing. Andy was a very prolific racer for many years, raced from the 50s until 2012. And they had just asked, hey, we want to start bringing our pads to America. Would you be a distributor for us? And from there, he just kept adding on more lines, formulated his own line. And that's how we get the Porterfield brand. And then we're just a distributor for a lot of other trusted companies within the racing industry.
So when did Porterfield get started?
1986.
Long-standing history there, almost 40 years in the business. So that's really cool.
Yes.
So you guys know everything about brakes.
Well, there's a lot to know. I definitely take the time to do some research to get to know the products, how they kind of interact as the new technology comes out. So there's always a lot more that can be known. I try to know as much as I can possibly know.
Well, there's a lot of people that say, especially in the racing world, well, brakes, what good are those? All they do is slow you down. All joking aside, there's a lot of other people that don't really understand how the mechanics of brakes work. I press a pedal and the car slows down. There's a lot of different things happening in that simple sequence. So let's talk a little bit about how brake systems work, how ABS works, kind of at a general level to get people up to speed.
Yeah, I mean, it is, you press the brake pedal, it pushes a piston in the master cylinder, which pushes the fluid through the brake lines, whether that's the hard line at the very beginning or towards the caliper, and then the actual either braided line or the rubber hose pushes that towards the caliper, and then that fluid pushes the piston out, which then pushes the pad up against the rotor surface, creating the stop.
And anti-lock braking systems, I mean, they've been around since the 80s. How do those exactly work?
So ABS works by releasing and reapplying or pumping the brakes to a wheel in heavy braking. There's a sensor that detects any kind of locking within the brake system or at the wheel. It can help benefit if there's lockup issues or flat spine tires, things like that in racing. But that's really where like the brake finesse kind of comes into play. And, you would try not to kind of engage your ABS, generally speaking, in a race car.
That's a very true statement. A lot of people nowadays didn't drive or didn't grow up with or don't drive vehicles that are pre-ABS cars. I was fortunate enough to learn on a pre-ABS car, which meant that there was another driving technique that is rarely used anymore in racing known as threshold braking, which is the precursor to ABS, knowing how much you could squeeze the pedal or even pump the brakes to get it to not lock up going into a corner. I still enjoy driving cars without ABS. Again, I grew up without those nannies, let's call them what they are, in place, but they are essential nowadays for your everyday car, especially in bad weather conditions and things like that, where it all happens so quickly, it's very hard to react. So that being said, you mentioned braking is more complicated than just pressing a pedal and something happens. There's a lot of terminology around braking. Sometimes people have misconceptions about what these terms mean. And so I kind of want to quickly go through what they are, kind of explain what they are, maybe do some myth busting here. So the terms in question are fade, warping, bedding, uneven wear, boil back, knockback. And then we can even talk a little bit more about how traction control and stability control plays into the braking system.
Yeah, so the fade is basically a loss of frictional resistance due to meeting the limits or the capabilities of the friction materials that you're using. The pedal will remain firm, but more pedal pressure would be needed. And that's obviously something you want to avoid in a race car situation. So you would make sure that the temperature ranges are matching up to what you're seeing in your car. So it's very important to keep getting the data while you're racing as well. A lot of people forget to gather data.
And we'll talk a little bit more about the heat ranges of pads as we go along, but fade comes from the fact that you've basically superheated the pad and it can no longer create any grip on the rotor, right?
Correct.
So what about warping? That one comes up a lot. Is warping a real thing? Can you really warp a rotor?
I think the misconception is that when people say I warped a rotor, they're thinking that they warped the whole rotor. A rotor is very rigid and very solid as a cast iron piece. When you warp a rotor, you're warping the surface area, the part that the pad contacts, not the whole rotor itself. Sometimes warping is not exactly what happens. Sometimes it's uneven pad transfer that people associate with being a warping problem. But rotors can absolutely warp the front surface area. And that's just, again, due to rapid heat generation. It just rapidly happens where you're rapidly rising the temperature beyond its capabilities, it'll warp. Sometimes if you duct it wrong, we'll talk about that probably later. If it's ducted wrong and you're cooling portions of the rotor and not other portions of the rotor, that can cause some warping because there's a give and take with the temperature ranges. Causes cracking too.
And there's other things that can occur as well. Like you can create grooves in the rotor surface. I've also seen rotors become glazed because if you think about it, as the metals are heating up, expanding, contracting, and cooling back down, you're almost going through like a forging process. If you've ever seen like a knife being made, it's not getting quenched. That's probably one of the worst things you can do, probably throw water on the rotors, those kinds of things. But there's a whole process to the metallurgy there that people often forget. And this is what makes it super complicated. My pet peeve is when people throw that phrase, my rotors are warped around a lot, not knowing what it really means. To your point, that big cast iron rotor, it's hard to make it a big wavy shape, an exaggerated warp. There's something else going on there. In the old days, you could quote unquote turn a rotor, put it on a lathe basically to re-smooth it out. Is that still the case now with all these specialty cross-drilled and slotted rotors and things like that?
You can absolutely still turn a rotor. Rotors tend to be more throwaway items, especially when we're talking in a racing field. Once a rotor is maxed out or having that issue where you would want to turn it, it's already done. You're better off just starting with a new surface and a new rotor altogether.
So for the guys that go to the track and are changing their pads there in the paddock, hey, I got my race pads in a box, just got them brand new. They smell great, right? They throw them on the car. And those of us that have been around the block a few times go, hey, aren't you going to bed those in? Inevitably, the driver goes, what? What do you mean bed my pads? What are you talking about? So why don't you walk us through what that process is really all about?
Yeah, bedding is very, very important, mostly when you're talking about race pads, just because in the street applications, a lot of times pads are designed to be pre-bedded because obviously skill sets for different people are not the same as they would be for track pads. So track pads, very, very, very important to bed in the pads. And the specific bed-in procedure can vary by brand. They know what's best for their applications. In our opinion, all bed-ins should be a gradual increase in temperature over the braking styles. It should never be 100% stop from 60 to 0 8 times. That is too rapid. You want to use maybe 60% pedal pressure and do 60 to 20 a couple of times. And then you're gradually increasing the pressure that you're applying to the pedal, as well as increasing the speed at which you're slowing. That way you can gradually bring it up to that max point. And what you're doing is you're laying a layer of what they call adherent friction. So when you talk about brake pads, there's two main friction types that are playing a role in your overall braking, which is abrasive friction and adherent friction. It's important that you lay that layer of adherent friction down there because it sets the foundation for all future braking. And without that, you're going to get those uneven pad deposits resulting in vibration and the warping thought process because it's not ever going to lay properly. So abrasive friction breaks down when it contacts the discs, much like sandpaper is abrasive friction. You scrape it across someplace and it rubs away. And so if you had a pad that was mostly abrasive friction, it would wear out more quickly because it's just, going along. It needs that adherent friction to wear longer. Conversely, the adherent friction lays down the thin layer of material on the discs and it bonds and reforms and comes apart. If a pad was just adherent friction or mostly adherent friction, then the temperature ranges would not be as high because that's not what it's really designed for. It's designed to be the buddy of the abrasive friction and help it do its job. The way that the companies make different friction levels and different types of pads and how they feel different is that mixture, that balance between adherent and abrasive. Obviously, other components that go into it, but those two are the bigger primary factors.
And a top tip from our paddock has always been, even with Porterfield Brakes, which we've been using for years and other brands, to get that initial glaze, the manufacturing kind of coating off of them, we grab them and we run them on the asphalt to basically scuff them in before they ever touch the rotor, which inevitably keeps you from running into the back of somebody on the grid because your pedal is kind of soft and the pads don't grab because they're not bedded in yet. But having them pre-scuffed actually makes it to your point where then you can go into turn one and brake normally in the next couple of turns and go deeper and go deeper. And by your third lap, pads are ready to go. You're ready to rock, 11 tenths or 13 tenths of your driving ability. And the pads will always be there or always be ready. So that's a top tip from our paddock. Scuff those pads on the asphalt before you put them against your brand new rotors. Uneven wear. You hear that term. Sometimes people complain, I got uneven pads. I'm going to flip them over. I'm going to put them back in the opposite way. Where does uneven wear come from on the pad?
So generally speaking, it always comes from the caliper. Whether the caliper is flexing, which is what could cause that uneven wear, whether the piston is not actuating properly, that could be due to a seal that's gone bad, any kind of fluid flow issue, things like that. It's generally related directly to the caliper. Obviously, there can be other factors like you put a caliper kit on there that didn't come there, like maybe you didn't put it at the right angle or kind of mount it correctly. It could be the pads in the formulation. That part is very rare. Like 90% of the time when I'm talking to customers and I'm seeing this kind of uneven taper wear, things like that, it's usually related to the caliper.
So I've noticed this a lot on multi-piston calipers. There's tons of them out there, Brembos, Alcons, Willwoods, etc. I predominantly run Brembo calipers, Porsche ones on my vehicles. On the leading edge of the pad, the way those Brembo calipers are constructed, the lower two pistons seem to actuate quicker than the top two, just the way the fluid moves through that monoblock caliper. I find myself at the end of the day having to flip my pads over so that they will wear back straight because my bottom two pistons basically eat the pad more quickly than the top two do. So something to be mindful of, keeping an eye on your pads and how they're wearing on your vehicle.
For sure. And then, like you said, flipping them, changing them inner to outer, left to right, those kind of things help you get that more even use out of the whole brake pad.
Yeah, you don't want to throw away the pads. They're not totally consumed yet, right? They're
Right.
expensive enough. You got to get every flap out of them you can. So now there's two other terms and they kind of go hand in hand. One is lesser known than the other. It's called boil back. And then there's knockback. I've heard knockback all the time. I had knockback in my BMW, which was super annoying. So let's kind of dissect what these two are and what they mean.
So boil back, I was kind of like, that's not a term that I've heard. But within the industry, there's inevitably verbiage that I'm not used to hearing. I'm used to hearing it a certain way. Are you referring to like a vapor lock situation?
When you get to fade and the pads are getting so hot, it's transmitting the heat back through the caliper, right?
Mm-hmm.
But the fluid is basically boiling back into the master cylinder. And if you have a car that shares a reservoir, like you have a hydraulic clutch system, then the clutch starts to suffer and it gets very, very soft because the fluid is boiling back through the entire system, which is different than knockback.
Not exactly like vapor lock, but it's basically boiling your brake fluid, which causes a mass amount of problems. Okay. When I was like thinking about this in terms of how it would make sense, I knew it had to be overheating the brake fluid. Because knockback, now that is a very technical type of situation. And trying to definitely trigger or pinpoint the exact things that you can do to kind of eliminate knockback is a little bit more tricky. Commonly, you would see it coming out of the S's prior to a turn. And that's because racing tracks are not generally perfectly flat. So sometimes you'll have inclines or declines and things like that. And S's, as you go through them, you're shifting the weight of the vehicle left to right, and it causes flex. And so then the hub and wheel bearing are deflecting. And so then when that happens, the caliper is mounted on a rigid surface. And so that doesn't move as much as, say, the hub and wheel bearing are. And so that causes the rotor to hit the pads and push them back. So then now the pistons are going back. Then when you go to brake, the next time as you come out of that, you're not aware that now everything has pushed back. And so you push the pedal, and now the pedal goes to the floor much further than you were anticipating. And you're trying to make this turn into the corner. So the best way to kind of help eliminate that is you can typically know as you're going around the track which sections are going to have that happen. And you just tap it after you come out of that section prior to going to the corner that's causing the issue. That'll get the pads back aligned and where they need to be before you need to make that stop. But obviously looking at how you can better make the system more rigid, whether that's also getting like anti-knockback springs, which are not always something that you can do depending on the calipers that you're using. Things like that will help. It's worse, the knockback, the larger the outside diameter of the rotor is, just because of the size and how much it'll deflect more than if it's smaller.
And your tip was right on the money. For those of us that suffer from knockback, one of the tricks that we have to learn is how to left foot brake. Getting in preparation, especially going down a long straightaway, something like VIR, Watkins Glen, you're tapping that brake pedal with your left foot, basically pumping the brakes back up, making sure that your pads are there. So when you go into turn one at 120 miles an hour, the car actually stops. The first time it happened to me with my BMW, it was scary, but then I was like, oh, I know what this is. I know exactly what I need to do. This is annoying, but it is part of driving that car. So, it is what it is. Other BMW owners I've met have complained about, man, this car really, it chews up rear pads a lot. What the heck is going on? I've answered that question probably more times than I'd like to. And it actually goes back to stability control and traction control. So how are those tied to the brakes?
Yeah, again, like you had said, like the nanny kind of system, as far as like ABS would be to brakes, to traction control is to steering and things like that, and controlling how the car is maneuvering and being able to stay in a more controlled manner than being more loose.
Yeah, and a lot of these newer systems leverage the rear brakes because they're not nearly as severe in terms of bite, right? The front end is doing 80% of the braking. They use those rear brakes to stabilize the vehicle. So by applying a little bit of brake in a corner or applying both, they can settle the car down and keep it from being in a skid or stepping out, things like that. So folks that have those systems enabled, they're chewing up rear pads all the time. And so that's the result of all of that.
Yeah, it keeps it from transferring too much of the weight to the front. But I think a lot of people, admittedly, if I can offer another tip, is absolutely put race pads in the rear. I can't tell you how many times people are like, it's the rear, it doesn't do anything. Absolutely.
Put sawdust back there. Yeah.
It does something. It helps to keep the car more balanced. If you have only braking in the front and the rears just give out, you're going to get a lot more nosedive and wear the pads a lot more and, be a little bit harder to steer and things like that.
So since you brought that up, it's a really good point. A lot of people are of the idea or the assumption that I need to put the same compound all the way around. And depending on the car, and correct me if I'm wrong, you actually want to offset the pads to create a natural bias, especially if you don't have a brake bias controller to offset the front to the rear.
You're absolutely correct. Yes. In most cases, I would say you should always go with a lesser friction in the rear for many reasons, the balance reason, but also temperature ranges. So the higher the friction, the higher the torque, the higher the temperature range it needs to be to operate well. So getting that temperature range to 600-700 degrees on a front pad is much easier than getting that in the rear. And you're not going to get the benefit of that higher friction, higher torque if it's in the rear and not being up to temperature. You're actually going to do yourself a disservice. So having something with lesser friction, A, it keeps the car more balanced, and B, that friction level will come in at that lower temperature that your rear is actually seeing.
Exactly. Yeah. If you put on, let's say, R4Es, or Porterfield pad all the way around, or a DTC 60 from Hawk all the way around, it's going to be like having ice cubes in the back if you're running the same pad in the front. I've for years have biased my pads front to back. I always start with an entry level race pad because I want the longevity. I want the endurance of the pad. I want to have to change them every 10 minutes. But up front, yes, I'm running something super aggressive. It balances the car out. It keeps it from doing something weird. And rear brakes also react slower than the fronts because the brake lines are like 8 times longer. So it takes a lot longer for the fluid to do its job, right? So you got to play into these natural mechanics when you're deciding. Don't just buy the same stuff for all 4 corners. So, folks, if you thought that was technical, we're about to go a little bit deeper and talk about the importance or the betterness of certain parts of the braking system. So I want to talk first about brake fluid. I have gone through so many arguments with people about wet and dry and boiling temps and what all that means and what fluid you should use. And just go buy Prestone off the shelf. You don't need that Castrol SRF, that hydraulic fluid you're putting in there. But there's a reason and a season for all of these different fluids. So let's talk about why brake fluid, first and foremost, is so important.
So, well, obviously brake fluid is what actuates your equipment. So if you don't have good brake fluid and you're not getting the temperature ranges that you need. So if you're boiling the brake fluid, you're going to get, like you said, potentially the boil back. But also if you have a spongy pedal or something like that, that's your brake fluid boiling. That's your car telling you that you've exceeded the limits of the brake fluid. Brake fluid, as we know, is hygroscopic, which means that it wants to attract moisture. It wants to absorb it from the atmosphere. So that's why you have a dry and wet boiling point. But what most people don't understand is that the wet boiling point, while it might be very high, the wet doesn't come into effect until it has 3.7% water by volume, which can take a year or two in an OEM type car. So that's a lot of moisture that will have been absorbed. So most race cars, generally speaking, will not be seeing a wet temperature. You should be bleeding the system after every race. Ideally, you would be flushing the system. Some people who really go for it, obviously, when we work in a brake company, we would do it all the time. But definitely bleeding out the brake fluid, getting rid of that spent fluid that was in the caliper, things like that, replacing it with some fresh stuff is always better. But yeah, the boiling point is very important. Mostly dry is the most important, again, because you're not going to probably get it to that 3.7% water by volume. Now, if you get yourself one of those fancy little things that can tell you what your moisture level is in your brake fluid, then by all means care about the wet boiling point. Obviously, it's a factor. If you leave it in there for a long time, then you at least know that the wet boiling point is good and high. If you overheat and boil the brake fluid, well, I talked about this a little bit ago about vapor lock. Basically, as you boil it, it creates bubbles. It could be trying to push through those bubbles versus pushing through the fluid. And so the pistons aren't actually activating because it's just bubbles. It's just air being pushed through there.
When you're choosing your brake fluid, how do you make the determination other than by pedal feel as to what you should be buying? Are there certain ways to gauge the temperatures, things you should be looking at, ways to do analysis and say, hey, I'm right on the edge? You never want to be close to red line on anything. So how do you make that decision on what to get?
Knowing what the brake temperatures that you're seeing within the system, like how hot the caliper itself is getting, will tell you a lot about what type of temperature the fluid obviously would not be as high as the caliper is getting. Most, I would say, all of the racing brake fluid, Motul 600, 660, anything that's racing oriented is always a good place to start. And then whether or not you have to adjust based on the ambient temperature outside, what tracks you're going to. If you're on the West Coast, you can probably get away with some low-level brake fluid going up at the streets of Willow. It's just meandering through. But like if you're at Laguna Seca, you're going to have something like the 660 or the Castrol or something like that. That is very taxing, like Road Atlanta, Sebring. Those tracks all require the most of your brake system. So you need to be prepared. The different cars will have different needs and different drivers drive differently. I think the minimum is putting race quality brake fluid in there. And frankly, they just don't make any that aren't up to snuff, if it's a real racing fluid.
And when you're looking at the big box store and all the different labels and brands and colors that exist, a lot of people just defer to the DOT number, .3, .4, and .5. How do you know which one's right? What does that even mean? Most people just go, oh, bigger number means better, right?
Well, the dot rating is really its resistance to moisture. So that's why .5 is a silicone-based fluid, because it's the most resistant to moisture. And so when we're talking about things not wanting to have a lot of water in there, that dot rating, it's just Department of Transportation. It says that it meets a certain parameter. And so that parameter means that it's most resistant to moisture, and that at different levels, different temperatures and things like that.
Which is great for a classic or collector car that sits a lot. You don't want to do brake fluid flushes all the time. But for a race car, the dot number really doesn't matter. It goes back to that dry boiling temperature again.
Exactly. Yeah. You wouldn't run silicone because that doesn't have any temperature properties whatsoever, but it's just the highest one. And then like 3 is not so great.
And a top tip that I learned, ask me how I know, if you do have a shared clutch and brake reservoir system, try to find a way to separate your reservoirs if you're running something heavy like Castrol SRF, because you will blow up clutch cylinders left and right because they're not designed for the added hydraulic pressure that the upper echelon of racing brake fluids produce. So something to keep in mind. Again, ask me how I know. Let's move on. Let's talk about the importance of brake lines. You know, a lot of people say, I got to run out. I got to get these stainless steel braided brake lines. Why?
Well, because the stainless steel brake lines will create a more firm pedal because there's no flex from with the rubber lines. Not to mention the fact that over time, the rubber tends to kind of degrade, and heat capabilities and things like that will be different with those as well. So stainless braided brake lines, if you can get them, really makes a difference.
We talk to all sorts of people all the time about the big brake upgrade, got to get the big brake kit. You know, if you talk to a Miata owner, they say the more weight you take out, the stock brakes become the big brake kit. You know, you don't need it. There are different schools of thought on what caliper is the right caliper for your car. Is that really true? Is that a myth? We should be really looking at temperatures and pads and fluids instead of dealing with changing the mechanical part of this?
I think anytime that you're trying to increase the horsepower of a car, then you should also be looking at the converse side of that and making sure that you're going to make those good stops. So I think if you're running the stock engine and everything on the vehicle is otherwise stock, the original brake calipers that are on there are probably going to be sufficient. Now that can change if it's, a single piston caliper, or it's those floating styles that aren't very rigid and very well at taking that kind of abuse. And then that's when you would get into changing the brake system. If you're a serious racer and you're very much focused on increasing horsepower and decreasing your lap times and things like that, eventually you're going to probably run out of its ability to make any other additional changes to your braking system as far as getting that extra up. Friction materials help a lot, but can it always be better is the trick. So if you need it to be better, yeah, it can be better. A lot of times better is relative. So it's obviously very important to look at the piston sizes that you're getting on the kit, whatever that you're getting, and make sure that that piston size is going to net you more surface area force than the piston sizes you're currently running, as well as the rotor size is a larger diameter than the current rotor that you're running, because that will also give you more force. We didn't touch base on master cylinders and the importance of a properly selected master cylinder. Now, obviously, if you're running a car that came from the factory, so your Mazda Miata, your Corvette, the engineers would have selected the proper size master cylinder for that application. But we've also talked about when you start changing things and putting different whatnots on there. I mean, I've heard of customers like, oh, well, I pulled, the front system off of this 911. I pulled the rear off of this 928 and I slapped it on there, good to go. But, I'm having this pedal issue. And so typically what people don't think about is when you start changing that, it's not part of a kit where you've discussed with Willwood or with Brembo or StopTech or somebody like the proper selection of a different master cylinder to go along with the change in the caliper that you're doing. typically if you're having master cylinder issues, it has to do with how much fluid it's displacing. So smaller master cylinder requires slightly longer pedal stroke to move the same amount of fluid. So like if you had a 1-inch, you would have a shorter pedal because it can push way more fluid through the system than a smaller one. However, you don't get the same amount of pressure. So you get more pressure with a smaller, less pressure with the bigger. So it's just kind of depending on like, oh, my pedal's firm, but I'm not getting any stopping power. It's like, well, have a little bit longer pedal and you're going to get the pressure that you want to make that stop. So it's just a matter of figuring out what size would be best for that application as well.
And that's very true. And in some of those cases, when you're doing these big brake upgrades, you can get away with swapping out hardware if it was something that was available from the factory, right? Let's say maybe you bought the base model Mustang and you go up to the GT brakes. Well, there's a really good chance if you cross match the parts, the master cylinders are all the same from Ford. So you don't really need to switch it out. It's when you go from the 2-pot factory brake to the 6-piston Alcon, now you have 12 pistons up front that you're trying to move. You don't have enough mechanical pressure to move all 12 pistons like you did the 4 or the 2 that you had up front. And that's where the bigger discrepancy comes into play. But generally, amongst the manufacturers, oh, I had the base Corvette and I upgraded to Z06 brakes. Yeah, you're probably pretty safe at that point to make that jump without having to change the rest of the hardware.
Right. So it's just a matter of like one more thing to check if you're not getting out of the system what you're hoping to get out. These are things that I would recommend, when people are troubleshooting things. That's one of the things that I bring up. What size master cylinder are you running? What's the setup look like? That kind of thing. And then the last thing that I cannot explain to people enough is make sure that the pad you're getting from the new kit is at least as thick as your current system. I have had customers who have a 16 millimeter, a 15 millimeter OEM pad, and they switch to a kit that's 12 millimeters. And they say, gosh, I put this kit on there and now I'm running through brake pads even more. And I said, well, you done took out 6 millimeters per caliper. And yeah, that's a lot.
And nothing else on the car changed. So it's still as heavy as it was before. And weight does play a major factor into the ability of those brakes to clamp down and slow the vehicle down.
Sure, yeah, a 3,000-pound car, even though the brakes are set up larger on a larger car. So like if you compare like a Miata to like a Cadillac, let's say, or a Corvette even at 3,000 pounds, and then the Miata over here at 26, 24, depending on which model it is, that's a big difference. And so that the OEM pads show that difference. That's why they're much smaller and different placed and things like that. But yes, definitely the downforce that is stopping a much heavier vehicle is going to play a big part.
And it's funny, you brought up something that conjured a memory from 20 years ago now. I remember when the original Golf R32s came out and they were doing their testing shootouts against the Lancer Evo and the Subaru STI, which came with Brembo calipers from the factory. And Volkswagen presented this 3,300-pound car with 2-pot Girling side pull calipers, like, factory stuff. And they're like, it's outstopping these high performance brakes. And to your point, they had 13.25-inch rotors with massive pads, and the clamping force of those twin pot Girlings was better than the Brembos because they were running these teeny little pads. And so again, there's a lot of mathematics that go into getting these cars to slow down. And I think the overall sentiment here is that the big brake kit isn't always the answer. There's a lot more, weight, the rest of your hardware, all that kind of stuff involved. So take the time to research, talk to other drivers and see what they're doing and see what has worked and what doesn't. Just don't go buy what's off the shelf and say, this is what I need because it looks cool.
Right. Definitely ask questions. We encourage people to ask a lot of questions here. We ask a lot of questions of our customers just because it's real easy to sell somebody $4,000 kit and call it a day. We would much rather communicate with them, give them all of their options and give them an honest assessment, even if that means not selling them $3,000 or $4,000 kits, if that just means selling them a $200 set of brake pads. It does us a better justice. And I think more companies hopefully kind of feel the same way that we do. It's more important to get somebody into the right thing than just sell them the wrong thing.
But you end up with customers for life, dedicated, loyal people going, Porterfield pads are amazing. I'm going to keep buying them. I didn't have to do anything else.
Yep.
But I think one of the most contested pieces of the braking system is the rotors themselves, right? We kind of alluded to this earlier. I have come to the school of thought by way of some veteran racers, and you mentioned it, they're disposable. And they always say, buy the cheapest ones you can find because all you're doing is wearing them out. There's a lot of people that get hung up on aesthetics, right? Oh, the cross drilled, slotted, this and that, and upside down and cryo dipped and all these geomet and all this stuff. When you're racing, I still believe, and somebody correct me if I'm wrong, if you're listening to this, cheap is the best solution when it comes to rotors. You want maximum surface area, not these cheese graters.
We always advise against cross drilling. Cross drilling in a racing situation is bad news. Going to crack, you're lessening the surface area of the rotor, like you mentioned. It makes it more prone to cracking. You'll get the cracks between the holes, and you'll end up having to replace the rotor due to that, not because of the wear like you would have if it was solid. At the most, we recommend slotting, but typically the strongest, most longest wearing, most durable for club racing, those kind of things, is going to be just a plain faced rotor. Most pads nowadays are slotted. They'll have a slot in the pad surface, which does the same thing as the slotting on the rotor. It helps release the gases that build up between the pad surface and the rotor surface so that it gives you a better contact and there's no buffering involved, so to speak. And I guess the only part that I probably wouldn't agree with is the cheapest is always better, because there's definitely quality landmarks for rotors. A cast iron rotor is a cast iron rotor. Yes, I will agree with you there. However, there are certain standards and certain things, like if they're using recycled metals versus brand new. So if you're running like a 6-8 hour enduro, or even a 12-hour enduro, you're going to want to get something more high quality so that you're not cracking a cheap rotor through the first race or, in the first couple of hours, so to speak.
I mean, the Miata guys right now are laughing, going, well, the expensive rotor is $17 and the cheap one's $13. So, whatever. But I feel your pain on the larger diameter rotors. It gets expensive quickly. Obviously, there's some specialty stuff out there, especially if you're driving exotics, some of the new Porsches with their, carbon ceramic brakes, all that crazy stuff. I think we're all in agreement. The more you do this, the more surface area you can get, the better braking experience you're going to get. And also, we've seen some nightmare situations with cross-drilled rotors where when they do crack, unlike a solid rotor that cracks, you hear it, it's bang, and you're like, all right, it's busted. All right, let's go. We'll put on a new rotor. Where we've seen entire chunks of rotors fall apart on a cross drill, and then suddenly the car's in the wall, all because we had these really cool looking cheese graters on the car. So the last piece of the racing brake system is the cooling ducts. I've fallen prey to this argument as well. Do they really work? Are they hocus pocus? Are cooling ducts worth it? Do they always work or not?
Fact, final answer. Much like everything else, they work if used properly. In order to have ducting work and do what it's intended to do, which is to cool the system down, you have to have it plumbed from as low at the front of the car, the nose of the car, as low as possible and as close to the center as you can possibly get it, because that's where the most amount of air is going to be at. And then you need to plumb it somehow where you don't restrict all of that airflow. So sometimes it gets really tight in there and you're trying to maneuver the hose or whatever you're using around, and it can collapse and things like that. Then you're going to be restricting the air. So that's the first part. The second part is ensuring that the hose is pointed to the back side of the rotor, never the rotor surface area. So not where the pad would be sweeping across. That is terrible to do because you'll only cool that section, and that will cause cracking because half of it will be hot, half of it will be cooler. Point it to the inside of the back side of the rotor. And if you can get a plate to keep that focused in that area, so on a ventilated rotor with it pointed to the back, it'll fan out the air throughout all of those veins. It'll shoot up in between the caliper and everything. So it'll cool that part down. It'll cool the rotor from inside out, completely the whole rotor at the same time being cooled down. That's when it'll actually work. Any other way, it's not going to do what it needs to do.
Being pointed closer to the center of the rotor also helps, if at all, to put some air across the wheel bearings as well, right? To try to cool them down so they don't suffer. The counterpoint to this that I've always made is, how do you know if they're really working? To your point, they need to be installed correctly, all this. If you don't have a way to measure the amount of CFM that's traveling through that hose, if you're just getting like a whisper of air, then they're not really effective. So why even have them? The other counter argument is, look at the design of your wheels. And people are like, wait, what do you mean? And I'm like, do you remember the old Ronal turbo fans from back in the 80s? The reason they were called the turbo fans is because they were designed to suck air through the wheel and cool down the braking system. So some wheels like Team Dynamics and others are designed to act as a fan and cool the wheels down because of the geometry of the spokes themselves. So sometimes that plays into the equation, but also you could generate enough air with the right wheel to push against the air that's coming through that hose. So there's a lot of things going on there. What is the answer? I don't know. I think it's maybe work with a tuner, put the car up on some rollers, try to push some air through there, see what's going on, see what the effective temperature differences, going back to what we were talking about before. What are our heat ranges? Heat is the enemy here, especially of the braking system. This one's very complicated. It's not just bolt on some parts from a kit. It's much more intricate, much more subtle in terms of getting it to work correctly for everybody's application.
Absolutely. I mean, I think in general, most things that have to do with the cars are, it's not just one simple answer, like this is it and that's it. There's nuances and there's obviously times and aspects where that's not going to work. Like you said, there's plenty of applications out there that are designed to take in more air. And if you don't have it plumbed correctly, you could be doing yourself a disservice where you were getting more air naturally in that area. Now you're obstructing it by trying to have this hose there that isn't properly pushed through. So you're not really getting the air. That's why I say it works if it's done properly. If you can't get it done properly, then you have to find another way to make it work.
So one of the things we left off the list, because we're going to transition to focusing heavily on it, are the pads themselves. Lots of back and forth about what is the right pad and how aggressive it needs to be and the torque and the bite. And there's all sorts of other terminology that coincide with pads themselves. So let's talk about the pads, how they're constructed. You talked about the adhesive properties and the abrasive properties of the pads, but there's some drawbacks and advantages also to your stock pad, your mixed use pad, and your race pad. So let's start off by going through all that kind of stuff.
Stock pads obviously are going to have the least amount of friction and the least amount of temperature range. So if we're talking in terms of racing use, they're going to meet their limits much quicker, probably within a lap or two. They are not designed to be stopped repeatedly at high speeds and creating and generating and keeping in that amount of heat. It's just not real world experiences for that. Secondly, I don't think, in our professional opinion, that there is a good dual purpose pad. It does not exist because, again, the requirements for street temperatures and friction is completely different than the requirements for track temperatures and conditions. People say, oh, but I'm only doing an HPDE. It's fine. Or I'm just going to do a track day. And if you're simulating race conditions, the car doesn't know it doesn't have a competitor.
A good application for let's call it a marketed mixed race pad might be autocross, though, where you need sudden stopping and bursts of heat and the pads cool right back down again.
I always just very carefully say street autocross versus like dual purpose, because then that kind of parlays into the track situation. But yes,
absolutely.
So like our performance street compound, Hawk make what they dub as a dual purpose HP plus compound. So that is great for having that higher friction, higher, broader temperature range than, say, a stock street pad, but not at the level of a track pad. But with those kinds of things, you get the dust, the squeal, and the occasional rotor wear. So if somebody is trying to avoid all of those headaches for their street car, then the HP Plus is not as desirable because it's not going to be great on the track and it's not going to be great on the street, but it kind of allows you to move back and forth. The Porterfield R4S can be used for street autocross, again, because autocross is generating that heat and that friction, but for a shorter amount of time. And then you have more like recovery time after that. If somebody is competitively autocrossing, meaning that they trailer the car to and from the track, and that's their dedicated autocross car, we have our vintage race compound. It's called R41. We recommend that because it has high friction level at low temperatures, best for when peaks will be under 1,000. And that works really well. I know a lot of the Miata guys, because it's a lighter weight car, even for road racing, they like the R41 as well. So lighter cars can use that for road racing, for autocrossing. We do it for vintage racing. But yeah, autocrossing is kind of that special niche kind of market where it can kind of go street or track as long as the temperature range comes in cold enough.
So when we go to the other end of the pendulum swing and we start talking about proper race pads, and we'll talk about how to tell the difference between all these, one of the things that I remind people all the time is don't run them on the street. They're like, what do you mean? You won't get them hot enough. What do you mean? Race pads like to be hot. They operate at high temperatures effectively. So let's talk about what it means to get a race pad hot and why they need to be hot.
Well, it goes back to the adherent friction and the abrasive friction technology. So the adherent friction is trying to do its job, but at 200 or 100 degrees, it doesn't work. It doesn't put that layer on and smooth it away. Like it needs more heat in it to be doing that job, to be laying the layer down and then sweeping it back up. They're designed to break the bonds, the crystalline bonds at a certain temperature. And so if you're not getting it to that temperature to make that reaction occur, then it's just not going to be what you're looking for. I know like ST47 by Revestis, very high torque, high friction level pad, requires the most out of the braking system. If you run that cold or drive it on the track, it'll shudder, it'll do all kinds of mean, nasty things. That's that adherent layer not being able to do it. And so it's creating that vibration and that uneven pad transfer because you have to run it hot. And that's just part of mixing in the abrasive friction and the other ingredients where they're designed to react and to change their structures at those higher temperatures. So typically when we talk about most high ends, the higher torque, the higher friction compounds, you got to get those 500-600 degrees. Like they want to be operating between 600 and 1,000 all the time, if not higher. To 1,500, most of these pads will go no problem. And that's going to be like your DTC 70s, your ST47s, even 60 likes to be a little bit hotter than most. So when we talk to customers and we're trying to figure out what range they need to be in, obviously as a brake company, it is our job to know the parameters of every single brake pad that we carry, which is what I go back to saying, like, I'm just always learning. I'm always trying to talk to Performance Friction, talk to Revestis, talk to Paget, talk to whoever I can and learn the ins and outs of all their compounds. So, we definitely have some that work better at the lower end temperatures. Like I was saying, the R41, the Porterfield R4 has good cold friction. It comes in around 200. So it can be used for rears for those lower heat applications. Like Performance Friction, they like to run real hot too. And just talking to people and seeing how they're using their pads and what they've used before is always really helpful, whether they liked it or disliked it, or I haven't been racing, I'm new. So like, obviously if somebody's new to racing, I'm not going to throw them into 47 and be like, hey, sink or swim, buddy, have a good time. Those are high friction, high torque. And when we talk about friction and torque, the torque is how quickly that friction responds. And so the higher the torque level of a pad, the more brake finesse that you have to put into the pedal. Because once you get those into the temperature range that they need to be, they're almost like an on-off switch. So if you treat a high torque pad like a moderate or light torque pad, and you just really mash into that pedal and try to do a really extreme threshold braking, let's say, you could overslow the car very easily and flat spot tires and things like that, because it's going to react much quicker than a moderately torqued pad. It's a matter of knowing what you're trying to get out of the car, how hard you're pushing the car, the temperatures that you're seeing. That's really important to knowing where to put the most emphasis or what's mostly needed out of the system. So the more that people know about their expectations about their car, about how frequently they're going to use it, what tracks you're going to, that's important too. Because, I said before, some of these tracks are not very taxing on the brake system and you can get away with something very minimal. But then if they're primary track is a track like Road Atlanta or Sebring or something, that's going to be a very different animal than what they're going to need for something that's very forgiving on the brakes. Trying to figure it out. And sometimes, you need to have two different sets of pads. For those tougher tracks, you have this, it's going to work really great. And then for the ones that aren't, run this because you're not getting them up to the temperature. And that's why you don't like your braking.
You bring up a really, really valid point in the sense that understanding what you want to get out of quote unquote the bite or the torque of the pad is important to your driving style as it is to a lot of other things. Because if you're big on trail braking and you have an overly aggressive pad, especially front and rear, and you haven't biased them right, it'll cause that car to do all sorts of weird stuff that you weren't expecting. You're like, oh, this thing handles like garbage. No, it's your pads that are overbiting in the corner and causing it to just wash out and do all sorts of stuff. So dialing that in, I've played with pads for years until I figured out what worked. I predominantly switched between R4Es and DTC 60s. They're very similar pads. It depends on what's available at the time, especially during COVID. Supplies were low, but I go back and forth. But I know how they feel. I know what they're going to give me. I know where my car is weighted and what I want it to feel like in the corner. But I also put a slightly more aggressive pad in the back to cause the car to rotate. I want it to be loose in the back on entry, things like that. So again, playing with those pads plays into the setup of the suspension as well. It's just amazing how this stuff works together. But I think the confusing part is just like when we go back to that scenario about the brake fluid, when you're looking at all the pretty colors of all the boxes and the fantastic names that they all have, how do you know the difference? Right? Is there a specific go-to number? Like if the rated low temperature is 500, you're into a race pad, or is there a clear defining factor that says this is the difference between street, mixed, and race?
Some companies post temperature ranges, friction levels, things like that. It gets tricky because over the years, there's been admittedly some temperature graphs that I have seen where I'm like, I don't know about that. I think because if more than one or two people put out misinformation in their graphs, then now the next person who puts out a graph has to adjust their real graph to match the fake graph that somebody else put on. So it gets very warped and very confusing because if somebody posts a real one, you'd be like, well, theirs is garbage. But then you run it and you're like, it's not. It's just kind of trying to figure that out. Friction levels, typically they should be able to tell you about where they are. Again, like performance friction does not tell us that. They don't tell us temperature ranges. Generally speaking, they don't tell us specific friction levels. But based off of testing and what we know and things like that, we can say, well, it's like this one, which is here. Most stock pads are a 0.2 to 0.3 friction. Performance street pads would be more around a 0.4. And then the race pads would come in between 0.5 and like 0.7. It's kind of like earthquakes, right? Hurricanes or whatever, they go up exponentially. So the numbers aren't very indifferent, but you would know based off of where those are at, where you should be at as far as what you're trying to get out of the car. The number goes up and so does the temperature range.
They're correlative. So that's good. The other side of this, kind of the darker side, in my opinion, because I don't care what my car looks like when I'm at the racetrack, but there's a lot of people that do. And you hear all the time, I want a brake pad that doesn't make any dust. I want my wheels to look spotless all the time. They're out there detailing their car. I'm like, we're at a track, man. You're going to end up with slag from the tires, junk, chips. It's like, whatever, right?
Mm-hmm.
What is your recommendation on these supposed high performance pads that are low dust or super clean or made of mysterious things like ceramic, and things like that? Are they for real or are they for fiction?
Well, for performance street use, low dust, low squeal pads are fact. Porterfield R4S is, as you described, those mythical creatures who do not, more so when they say don't dust. Okay, so again, when we go back to abrasive friction, that's the part that wears away like sandpaper, right? So that has to go somewhere. It doesn't just magically go poof. It's not a vapor. It's an actual thing. The way that they kind of get it to be dust-free, or I can only speak for us, our dust is a lighter color. So when it comes off of the pad, it's lighter in color, but it's also lightweight. So it doesn't stick to the wheel. It just kind of goes into the air. Yay, like every other brake dust does. So therefore, it's not adhering itself to the wheel. And so then there's the perception that it's dust-free. It's not dust-free. It's dusting, but it's not sticking to your wheels where you have to physically see it. And if it does, it's a very light color and not like super dense and heavy and things like that.
And I won't name names. Some pads are extremely dirty and the brake dust is very sticky. And I've written about it now year after year in something we call the battle against brake dust. So I want to ask your professional opinion. Do you have any cleaning tips for those of us that suffer from pretty wheels that are sort of ugly all the time due to their brake dust?
Much like everything else, there's not a clear, concise answer because different wheels have different treatment methods that will work with those wheels. So I would never want to give somebody a blanket recommendation, but I would say the quicker that you remove that brake dust, the better off you'll be at removing them, because typically the dust that is very heavy tends to be corrosive. So the longer a corrosive material is allowed to sit, the more damage it will do, especially in damp or wet conditions, which tends to activate or accelerate the corrosiveness.
Yeah, and to add to that, as a plug for one of our previous episodes, one of the things I found that works really, really well is if you use a wheel treatment. There aren't a ton out there. Zymol makes one called Wheel Coat, and it's designed with natural materials. And I've shown videos where after a session on track, you can wipe down a wheel with super aggressive brake dust on it with just a napkin and nothing else, and it repels the brake dust. So if you're that concerned about it, I highly recommend looking into a wheel protection, a coating that you can put on there, not the same coating you would put on the body panels of the car, something specifically designed for wheels. I can't recommend the Zymol stuff enough. There are other competing products out there. That's the one I've chosen to go with. You can tune into a previous episode with Zymol to learn more about those products if you're interested. Since we're talking about pads and we all have our loyalties, let's talk about the different brands that Porterfield resells, along with the house brand, the Porterfield pads themselves. What can somebody call up and order from Porterfield, from you, Wendy?
We sell, obviously, the Porterfield, our in-house brand, Performance Friction, Hawk, Raybestos, and Paget. And we carry from Paget and Raybestos, it's only their race line. We don't carry anything for their street line. We're a reseller for Brembo, so we can get obviously any of the Brembo racing brake pads as well as the street stuff too.
I've also heard that if you don't have a pad available in the catalog for a vehicle, that Porterfield, you can send old pads because you guys can do something with the backing plates to actually create pads. Is that true or not?
So we don't actually need your backing plate. So we get this a lot. I will say as a disclaimer, recently, Raybestos, they don't mind that we make custom pads. So everybody that we sell knows that we make custom pads. We make no qualms about asking and making sure that that's cool with them. So Raybestos has asked, if you're going to make our pads into something else after you finish the product, please just relabel it yours so that the liability is yours since we don't have control over what you do. Understood. So if anybody sees the pads labeled or in a Porterfield box, I assure you it is still Raybestos product. We're just confirming that we're doing it under their regulations and how they would like it to be. Generally speaking, we would put it back in like a Hawk box or a Paget box. So that way the customer knows like this is what we use. This is legitimate, but per their request, we had to make that change, which is recent. Basically, we start with a finished product, whether that's from Hawk or Paget or PFC or Raybestos. And it only comes into play if it's a pad that they don't make somebody really wants. So like, let's say a Mazda Miata, the newer ones without the Brembo system. I know a lot of people like to run the HP Plus on those Miatas for dual purpose. They don't make it, so we make it. But we have to start with something that's already finished, and we just cut it to the shape that you need. So in theory, you can think about somebody giving you a round cake, and you're like, well, gosh, I really want a square one. Okay, cool. I'm just going to take a knife, and I'm going to cut the little corners off, and I'll make it square. Poof, it's square. It's kind of the same thing with the brake pad. We're not pouring their material. We're not relining on a backing plate. We're starting with a part that they made themselves, and we're just changing the shape to match what you need.
Right. And so this is important for a lot of guys that have vintage cars, right, where they might have something odd. I personally have a vehicle that I'm working on now that has Bremtech calipers on there. Those were discontinued 30 years ago now. And I've been going, do I replace, and these are 4-piston calipers. I'm like, do I replace?
It's basically like a Willwood Superlight pad, but it's flat across the bottom.
Yeah. So I'm kind of like, where do I go to get pads? I call Porterfield and say, can you make me one, or do I replace all of my calipers? That's kind of the decision I'm faced with. And I'm sure a lot of other people are too. So I want to remind people that you guys offer this service, and it's super important, especially if you wanted a more aggressive pad or something that you're used to using on your more germane race car, that you have this option available to you. And I think think that's super awesome.
Yeah, it's kind of what we're known for. It sets us different than most other companies, that we have that custom aspect.
So I wonder, and this comes up a lot, I hear, oh, well, Porterfield's just a rebadged Raybestos, whatever. Is that true? Or is it sort of like...
No, we've been in business. Well, okay, I've been here for 25 years. When I first started in 1998, we already had our Porterfield line. We did not start selling Raybestos until like 2008 or 7 or something like that. First of all, just to debunk that, we were in business selling Porterfield pads long before we were selling Raybestos race pads. But no, we manufacture our own brake pads. It is completely separate. They're completely different. If you took a Raybestos pad and a Porterfield pad and you put them side by side, they would look visibly very, very different. We are not the same company. I think people, they kind of think that it's the same only because we were probably one of the earlier club racing companies that started pushing the Raybestos out there before it was really readily available to a lot of other club racers. So I think they get it misconstrued, but definitely they're two separate companies, not related, not the same thing.
And our last bit here in the technical part of the conversation, checking our brakes. How do we really look for wear and making sure we're getting the optimal performance out of everything? What are some of your recommendations for doing the operations and maintenance of our system throughout the season?
Well, obviously, it's as simple as a visual inspection. I mean, brake pads are going to be very easy to look at and see if your pad material is low. We recommend replacing pads when you have only a 1/4 inch material left. Some people, that's not their comfort level, whatever floats your boat. But we say no less than a 1/4 inch of material. Rotor is the same thing. If they're getting really warped or they're getting really grooved, you have that visible etching or ripples or whatever in them. It's time to replace that. The calipers, inspecting your boots, inspecting your seals, inspecting the pistons, make sure that there's no pits or anything that got in there. Occasionally we've had people where rocks have kicked up and got into that caliper system and put a huge gouge in the piston, and it was causing it to leak. Things happen. You just don't know. So just visual inspections of all of your equipment, just like you would do anything else, checking it to make sure it's all working order.
So what other wear and tear or specialty brake related products does Porterfield sell outside of pads? Do you guys have rotors, brake lines, fluids? What else do you carry?
So we carry Tilton's full line. So anything that Tilton sells, master cylinders, pedal assemblies, same with Willwood, we carry that. We carry products by DEI, which is dealing with the heat situations. They have a great floor panel kit for Miatas. Since we've brought that up a couple times, just figured I'd shout that one out. Brake fluid, C-Treb oil coolers, carry Redline oil, a lot of undercar parts, mostly something that would be somewhat related to brakes or other kind of niche type market situation.
All right, Wendy. So we covered a lot of ground, and I want to ask, are there any shout outs, promotions, anything else we didn't talk about with respect to Porterfield? This is your opportunity to let the audience know.
Well, we're here for the racers. That's what we love, talking to them. Even if it's just a question that's maybe not going to net a sale, we're here to help. We're here to answer questions and educate people. Same as I'm ready to be educated. If I said something in this podcast and somebody was like, she's crazy, that's fine. Give me a call. I'm at Porterfield all the time. And you just let me know and we can talk about it and we can both learn. And I think it's just a really good industry and community to be involved with. Porterfield just tries to do what we can to help the whole community and keep people out there racing and having a good time.
Absolutely. And for those that don't know, this is the opportunity where you should be checking your membership to your different car clubs, because some of them do have discounts and promotions with Porterfield. I can name a few off the top of my head right now, but this is part of that value incentive package, why they want you to sign up for these annual memberships. So check and see if Porterfield is on the list, so that way save a couple of bucks next time you need a set of pads or rotors or brake fluid or whatever it is.
Yep, racebrakes.com, and we do it at NASA, SCCA, and VARA are the discounts.
Porterfield Brakes services all kinds of performance applications related to your vehicle's braking system, including brake pads, rotors, calipers, fluids, and full brake kits, as well as other performance and racing components like suspensions, oil coolers, starters, heat protection items, batteries, and much, much more. If you need any brake pads for virtually any car or truck, they have them or they will make them for you. So be sure to check out Porterfield Brakes before making your next purchase. You can find find Porterfield at www.porterfield-brakes.com or at Porterfield Brakes on Instagram and Facebook. And for more details on everything we talked about in this episode, head on over to gtmotorsports.org and search "What's Stopping You" for the follow-on article for this episode. And by all means, give Wendy a call. She's a wealth of information and happy to have a conversation with you. And with that, Wendy, I can't thank you enough for coming on the show. This has been an absolute education, and I really appreciate you taking the time to stop and talk to us about brakes.
Well, thank you so much for having us. It was great to chat with you.
If you like what you've heard and want to learn more about GTM, be sure to check us out on www.gtmotorsports.org. You can also find us on Instagram at Grand Touring Motorsports. Also, if you want to get involved or have suggestions for future shows, you can call or text us at 202-630-1770 or send us an email at crewchief@gtmotorsports.org. We'd love to hear from you.
Hey everybody, Crew Chief Eric here. We really hope you enjoyed this episode of Brake Fix, and we wanted to remind you that GTM remains a no annual fees organization, and our goal is to continue to bring you quality episodes like this one at no charge. As a loyal listener, please consider subscribing to our Patreon for bonus and behind-the-scenes content, extra goodies, and GTM swag. For as little as $2.50 a month, you can keep our developers, writers, editors, casters, and other volunteers fed on their strict diet of Fig Newtons, gummy bears, and Monster. Consider signing up for Patreon today at www.patreon.com/GT Motorsports. And remember, without fans, supporters, and members like you, none of this would be possible.